Welcome to derivatives of inverse trig functions. In this section, we're going to look at the arc functions, arc trig functions like arcsine, arctangent, arccosine, arcsecant, arccosecant, and arccotangent. Okay, so first let's take a look at arcsine. Now, what does this mean? What is y equals arcsine of x? Well, this means that when we put in a number like 1/2 or 0.5 into this function, it's asking sine of what angle equals 1/2. And we know that sine of pi over 6 is equal to 1/2. So that means that arcsine of 0.5 or arcsine of 1/2 is pi over 6. So it's the inverse function of sine. And you'll see this in your calculator as sine to the -1x. And I don't like using that notation. We're going to use the arc notation because that's more phonetically and correct. The invert, that's bad. So just ignore that. So we're going to use the arc sine notation here. Now let's try to take a derivative of this, and we're going to use some trig identities to come up with a rule here. So in order to take a derivative, let's rewrite it and say that if y is equal to the arc sine of x, then the sine of y is equal to x. And if we take the derivative of both sides with respect to x, or implicit differentiation, we get cosine y dy dx is equal to 1. Okay, little chain rule there, the dy dx is going to pop out. And so if we solve for dy dx, well, that's simply equal to 1 over cosine of y. Now you might say, okay, we're done. Dy dx equals 1 over cosine of y, or in other words, it equals secant of y. Well, here's the thing. We want something in terms of x, and this is a derivative only in terms of y. So let's try to fix this. Let's use some trig identities. And one that we're going to use here is cosine squared of y plus sine squared of y is equal to 1. So if we solve this for cosine of y, that's just going to be the square root of 1 minus sine squared of y. Well, what is sine squared of y? Sine of y is x, so sine squared of y is 1 minus x squared. So that means that we can rewrite this to say that dy dx is equal to 1 over the square root of 1 minus x squared. Now this is a lot nicer. Why is this nicer than this? Well, because this is a derivative, dy dx, in terms of x. This is a derivative in terms of y, but if we don't know y, when we want something in terms of x, want to know how is y changing, well, now we know in terms of a function of x. So this is a rule, and actually instead of deriving all the other 5, I'm just going to give them to you, and in fact they're on the top of the paper that you picked up today in class. All 6 arc trig functions can be rewritten. The derivative of those arc functions can be rewritten as these rules here. So arcsine, the derivative of arcsine of u, can be rewritten as 1 over the square root of 1 minus u squared du dx. Now notice this is the chain rule here, the du dx. We've got to take the derivative of what's inside, and that's going to pop out and multiply by our 1 over the square root of 1 minus u squared. And each of these trig functions has its own rule. Now notice a little similarity here. All the cosine, arccotangent, arccosecant, all have a -1 out here. And notice all the other trig functions like arcsine, arctan, arcsecant have a +1. And notice the similarities that negative is the only difference between arcsecant and arccosecant. And that negative is the only difference between arctangent and arccotangent. And that negative is the only difference between arcsine and arccosine. Okay, so really there's 3 forms here, and then the co is just the negative of. Okay, so this helps us take the derivative of inverse trig functions. So let's take a look at an example here. If we have y equals arcsine of 3x squared, and we want to take the derivative of that, well, we know that d dx of arcsine of u is equal to 1 over the square root of 1 minus u squared du dx. So this is just our form that we're going to use here. Well, our u in this case is 3x squared. So we're just going to put that in u's place, and the derivative du dx is simply 6x. So this dy dx is going to be a 6x, that's from the du dx, is going to pop out up top. Then we have 1 minus 9x to the fourth, all under a radical. And we just leave it as that. We can't simplify that anymore. And so it's simply 6x over the square root of the quantity 1 minus 9x to the fourth. And what does this tell us? Well, this tells us the slope, or the instantaneous rate of change, the slope of the tangent line of our function y equals arc sine of 3x squared. Okay, let's take a look at another one here. If we have y equals arc secant, now we know that arc secant, d dx of arc secant of u is going to equal 1 over the absolute value of u times the square root of the quantity u squared minus 1 du dx. Okay, so our u in this case, well, that's going to be our u, the negative 5x cubed plus 1, and our du dx is going to be negative 15x squared. So we just simply just put this in, substitute it in, and we get dy dx is equal to a negative 15x squared all over the absolute value of a negative 5x cubed plus 1, and then the square root of the quantity negative 5x cubed plus 1. That quantity is being squared, and we subtract 1. Now, you look at this, and this is kind of a mess, and there's a lot going on, and unfortunately, we can't simplify anything. We can't simplify this in, factor out something of the negative 15x squared that's going to cancel out with anything on the bottom. So we can simply leave this like that. Okay, so what I want you to do before class tomorrow is try that sheet that you picked up. Try doing those 8 problems and use the 6 rules that we have for the inverse trig functions. Take their derivatives, maybe work a little algebra, and come in tomorrow with that complete. Thanks.